Under physical world, we'll study the role of physics, fundamental forces, and energy. Physical world is the visible and invisible material world around us. Physics is the part of science and is the study of nature or physical world and natural phenomena and deals with certain laws governing the natural world. Scope of physics can be categorized under two domains. One is classical physics and other is quantum physics. Classical physics deals with material of macroscopic nature, whereas quantum physics deals with materials of microscopic nature. Macroscopy material covers terrestrial and celestial astronomical bodies, whereas microscopic material covers atom, molecules, and nuclear phenomena. Classical physics can be further sub-categorized as mechanics, electrodynamics, optics, and thermodynamics. Mechanics deals with motion of bodies and governed by certain laws like laws of motion and laws of gravitation. Electrodynamics deals with electrical and magnetic phenomena associated with charged and magnetic bodies. Optics deals with the phenomena involving light that includes working of telescope, microscope and thin film etc. Thermodynamics deals with changes in internal energy, temperature, entropy, etc. through transfer of heat. Fundamental forces can be categorized as gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Gravitational force is the force of mutual attraction between any two objects by virtue of their masses. Electromagnetic force is the force between charged particles. When charges are at rest, this force is attractive for unlike charges and repulsive for like charges. When charges are in motion, magnetic field created due to the moving charge give rise to a force on the moving charge. Electric and magnetic effects are in general inseparable, hence the name electromagnetic force. Like gravitational force, electromagnetic force does not need any intervening medium. Electromagnetic force is enormously strong compared to gravitational force. Gravitational force is always attractive, while magnetic force can be attractive or repulsive. Because gravitational force has been arisen by virtue of the masses, which is neutral by nature, whereas electromagnetic force has been arisen by virtue of charges which are of either positive or negative. The next fundamental force is strong nuclear force. Strong nuclear force binds protons and neutrons in a nucleus. In spite of the electric repulsion between its protons, Strong nuclear force is the strongest of all fundamental forces. It is charge independent and acts equally between a proton and a proton, a neutron and a neutron, and a proton and a neutron. Electron does not experience this strong nuclear force. The fourth weak nuclear force appears only in certain nuclear processes such as the beta decay of a nucleus. In beta decay, the nucleus emits an electron and an uncharged particle called neutrino. This weak nuclear force is weaker than strong nuclear force and electromagnetic force, whereas stronger than gravitational force. Maxwell unified electromagnetism and optics and discovered that light is an electromagnetic wave. Out of all physical quantities we come across, the quantities which remain constant and do not change with respect to time are called conserved quantities. If the quantity is force and the force is conserved, under external conserved force, total mechanical energy of a body remain constant. That is, sum of potential energy and kinetic energy remain constant. Energy is a scalar quantity. When all forms of energy such as heat energy, mechanical energy and electron energy are considered and counted, it turns out that energy is conserved. Law of conservation of energy is true for all forces and for any kind of transformation between different forms of energy. The law of conservation of energy is valid across all domains of nature from the microscopic to the macroscopic. Mass is equivalent to energy and is governed by the relation E equal to mc square, where c is speed of light in vacuum. In a nuclear process, this mass gets converted into energy and vice versa. This is the energy which is released in a nuclear power generation and nuclear explosion.